because you see, Legendre function which we learned earlier is also a special function. Now, why do we call it special? See, there are so many types of functions. If I have x, then sin x is a function of x, or x squared plus 2, that is a function of x. So these are all different functions of x, but then these may have some speciality, but they are not special in some way. Special functions are functions which have got specific applications in physics or in other branches of sciences. So looking at that means many physical problems, they take the form of these special functions, and so it has been, the necessity has arisen that we should study them separately. So in order to simplify some of our mathematical theories, some of the theories of physics, we require this special functions. And we have just completed the Legendre's function, and we will start with something slightly different from what we have learned earlier. That is, we will be learning beta and gamma functions. Beta and gamma functions. Now, beta and gamma functions are like this. They are also called the first and second Eulerian integral. So let us first define it. First, beta function. So beta function is usually written as beta like this, and like this it is beta mn. So this is what? This is beta function. Beta function is also written as beta function. So is equal to integration 0 to 1 x to the power m minus 1 minus x the whole to the power n minus 1 dx. So this is beta function, and let us see. So what will be beta? Suppose 4, 8 or 4, 7. This will be what? This will be 0 to 1 x to the power 4 minus 1, that is x cube, into 1 minus x the whole to the power, the second one, n, that is this is 7 minus 1, 6 dx. Students, this is a definite integral, and it will have a certain value, and it will not be very easy to calculate it. We have to find it. It will not even be very difficult, but it will take some time. You multiply this, find this 1 minus x to the power 6 and all this, whatever. So, and after that you put the values of 0 and 1. But after learning beta function, we will see how integration of this type becomes very easy, because they have got some fixed values, and so they can be conveniently used. So this is the beta function. Beta mn is 0 to 1 x to the power m minus 1, 1 minus x to the power n minus 1, where m and n are these, and they are obviously integers. They may not be integers also, they are numbers. You also have beta half, as you will see. So I was wrong in saying that m and n are integers. They are positive numbers. So the m and n are positive numbers. Now let us go to gamma function. So first we have defined beta function, and now we set out to do gamma function. See why we are doing this together, because you will see that they have got some connections between them. So this is gamma function, which is also written as this. Students, do you know this letter? This is actually capital gamma. So you know this gamma, which is the small letter gamma, and we are very familiar to this gamma. This is gamma function. And what is gamma function? Let us see. Gamma function is like this. Gamma n, I'm sorry, it doesn't have this part. Gamma n is equal to 0 to infinity e to the power minus x, x to the power n minus 1 dx. See, both are not very similar. Beta involves definite integral, where we integrate with respect to x from 0 to 1. But gamma function, here also we integrate with respect to the variable x, but the limits are from 0 to infinity. Here we have this exponential part, here we have x and 1 minus x, and here we have 1 is the exponential of this and the other is this. And look, here we have two numbers and here we have one number. So you have integration. Suppose I have got integration of, not integration, gamma 5. So what does gamma 5 means? It means 0 to infinity e to the power minus x. See, this e to minus x, this part is not affected by the number here. It remains the same, whether it's 5 here, 6 here, or whatever. And x to the power n minus 1. N minus 1 means 1 less than the gamma. So this is gamma 5, so this is 4 dx. So you will see again, this is one of the most useful expressions. So you'll see how we can use it. We'll see this. Now let us look at certain properties of beta and gamma functions, like this. So you will find that I'll shift between beta and gamma. So as the necessity arises, I'll do. So properties of beta and gamma function. Properties of beta and gamma function. So first of all, number 1, to prove that beta mn, in some books they write as capital B. So it doesn't matter as long as you know that it means the beta function. 0 to 1, as we have already described, x to the power m minus 1, 1 minus x the whole to the power n minus 1 dx. Now we have one property of definite integrals. So we have zero to a fx dx is equal to 0 to a f of a minus x dx. So students, do you remember this? This is a property of definite integral. So when I use this in this expression for beta, this one, so I write it like this. This is equation number 1. Thus 1 can be written as one was beta m comma n, which is equal to 0 to 1, 1 minus x the whole to the power m minus 1 into, see what I substituted here, instead of x I substituted a minus x. So in this function, in this beta function, we had x to the power m minus 1, 1 minus x to the power n minus 1. So what do I substitute? A minus x means, we take what is a here, a here is 1. So what I do, I put 1 minus x, x to the power m minus 1 into 1 minus x the whole to the power, this is a, so this is a to the power n minus 1 dx. I hope this is clear to you. So this is like this, which is equal to 0 to 1, this has to be like this, sorry. So what this becomes, this 1 is gone, so it is what? X to the power n minus 1 into 1 minus x to the power m minus 1 dx. So see students, is this not equal to beta nm by the definition? This one, when I look at this, so what does it, what have we just proved? We proved that beta mn is equal to beta nm. So it doesn't matter which we are doing. So this is the first property. Let us go to the second one. We go to second one, that is let us look at a property of the gamma function this time, number 2. So I am mixing them according to my convenience and your convenience actually. So once I'll do a beta, then I'll go to gamma and so on. Because why I'm doing this? So that you have the ease of learning, you can learn easily. Okay, so we have, let us look at gamma n. We had already described it as 0 to infinity x to the power n minus 1 and e to the power minus x. So we did put this in the here in the when we wrote the definition, but then it doesn't matter at all. So integrating by parts, integrating by parts, what do we do? Taking x to the power n minus 1 as the first function, what we have, that implies gamma n is equal to first function differentiation of the second function is like this, along with a minus sign, plus it becomes like this, 0 to infinity x to the power n minus 2 e to the power minus x dx. I'm sure you can do this simple integration of product of two functions by yourself like this. So which is equal to when you go on, this becomes equal to n